Thank you for the invitation indeed. It's an honor to be here. I will try to be quick. I will touch the subject of cloud computing. It's much closer to IT, or I will be closer to IT. The 2 days is more or less for telecommunication, but this is more or less much closer to IT as a speech. It's a big subject, but I will try to make it as concise as possible. So, what is cloud computing? If you ask today 10 people to tell you what is cloud computing, most probably you get
10 different.
Not 10, but more than one different answers. But that's okay. It's evolving. It's something which is evolving. So there are many different perceptions of what is cloud computing. Let's start from there. Let's also say that it's not something which is a revolution. It is an evolution. Okay? So cloud computing encapsulates an entire computing evolution of IT industry and many computing issues for many, many years. Technology issues and computing issues like grid computing, clustering, virtualization, storage management, networking, etc. has been evolving through the years. And today they have come to a maturity level and a critical mass level that combined together they give rise to what is called cloud computing. So as I said before, it's an evolution rather than a revolution. Back in the 60s, we've heard the utility computing coming from a professor in MIT many, many years ago. So it's an old story. In the 90s, we had the ASP model. ASP means that I put my hardware in the premises of a provider, a service provider, and I run my own software there. In the early 2000, we had the SAS, the software as a service model, where I don't own the software, I don't own the hardware, I don't own it, but I just rent it over the internet and I run it there from a provider. And in the late 2000, these days, we have the rise of cloud computing, where we have models like pay as you grow, pay as you use, leveraging virtualization and data center efficiencies existing as technologies today. Now, coming to the definition, believe it or not, we need a definition, and it's one widely used is from NIST. This is the National Institute of Standards and Technology in the United States, Ministry of Commerce. And if we look in this definition, every single word of it, it's important. Okay? So cloud computing is a model of enabling convenient, on-demand network access to a shared pool of configurable computing resources, like network server, storage, application, and services, that can be rapidly provisioned and released with minimal management effort or service provider interaction. It's a very concise definition. Now, let's see a bit more about the model, the deployment and service model. What is available today as cloud? So we have 4 different models of deployment to start with. So we can have private, community, public, and hybrid. Private means I'm a company, rather big, and I do set up my own environment of cloud computing for my own users. Community means I'm not a company, but I'm a community. For example, is the community of doctors, the community of hospitals, or all together, or the community of lawyers. So they set up a cloud for themselves. Okay? This is the community cloud. The public cloud is what is widely open to the public, like the Amazon, for example, cloud we have. So everybody has access to it. And hybrid means I am a company and I have a strategy to use both my private cloud and partly a public cloud or a community cloud. This combination is called hybrid cloud. Okay. The delivered models, there are 3. We start from infrastructure as a service. Infrastructure as a service means I pull together a set of servers and storage, and I put them all together, and I provide virtual usage of this hardware to the rest of the community. And this is just infrastructure as a service. So I provide hardware operating system. The second is platform as a service, a layer on top of that. So I put software like databases or middleware development platforms on top of the infrastructure. And I do share them, and I give them to the users as a database layer or a development platform layer. And the third is the software as a service, which is a layer on top again. So on top of platform, I put an application, and I do share it over the cloud. An application like a CRM application or an ERP application or a human resources application. Quite common these days. Easy to have this kind of offerings in the market. The essential characteristics that a cloud has are 5. First of all, on-demand self-service. Whenever I need it, I have it. The second is ubiquitous network access. So I access it from the network, from everywhere, anywhere. Okay, so I'm not restricted from where I stand in order to use these cloud services. Rapid elasticity means very quickly I get more resources to use if I need more power. And location-independent resource pooling means I don't care where the hardware is. I don't care. Could be in several places around the world. And it's a measured service. Very important. Measured means I know how much of it I use instantly, and I'm charged back for that. These are the very 5 essential characteristics of the cloud computing. Foundational elements and enablers, I don't mention that. It's what I said before. It's key technology which has been evolving through the years and has made this possible to happen today. Now, let me talk a bit more about data center evolution. I come from IT more. I come from a company which has to do with large data centers and customers. Many of our big customers are telecoms, the biggest actually in the world in the complexity. So I thought it is relevant to this discussion. It's important. So cloud computing owes a lot to what is happening in the large data centers as well as fundamental technology. So in the past, IT data centers, for every new need they had in the past, they just bought a server, they put some database, they put some application servers, they put an application, they run it. Okay? And then the next month they need another one, and they put another server, and then the next year and another and another. So I ended up to get today with situations in data centers with hundreds or thousands of computers. To give you an example, today there is the large banks in Greece. The number of servers, not desktops, the servers they have are the order of magnitude of 1,000, more than 1,000. Okay? So the next step was grid, was the consolidation of that. And this started happening in the last 5-6 years. So the companies try to pull together the various servers in fewer servers and make a grid of servers and have better manageability and less expenses. Based on that, today in the data centers, adding technologies like I said before, provided today like self-service, policy-based resource management, chargeback and capacity planning, we go from this consolidation to private clouds. So that's the path from the past to today to the private clouds. Okay. This is a journey under full deployment and evolution today. Not at the end, by far, in the beginning. Which is a strategy to migrate to cloud. This is on the table of the biggest companies today, or most of the companies today, of the CIOs and beyond. So first of all, we have to understand the various cloud types and various pros and cons. As we said before, we have various options. Then we have to select what applications to migrate and to which cloud model to migrate those applications. So we migrate them to an infrastructure as a service or platform as a service, or just to a virtualized environment. Do we migrate them inside the